In this section, we are going to look at even functions. You will understand the geometric and algebraic significance of even functions. Here we have the definition of an even function in algebraic form. If we have f minus x, it is equal to f of x for all values of x in the domain. And this means that the graph is symmetrical about the y-axis. Let us look at some examples. For example, the graph y equals x squared minus 4. The y-axis there is the mirror line. So it is said to be even when the y-axis is the mirror line. So once you reflect this curve into the y-axis, it should fit exactly on the other side. Other examples of even functions are like, for example, curves of the second degree. For example, we have, say, y equals x squared. Another example would be y equals to minus x squared, or y equals to, say, 1 over x squared. So curves of this family are said to be even. So I'm going to look at another type of even function, like trigonometric functions. For example, I have here y equal cosine x. Here, as you can see, the y-axis is symmetrical, and that would be the mirror line. So if you reflect the right hand side of the curve, it should fit exactly on the left hand side over there. Now what we're going to do next is to look at the algebraic significance of this, where we substitute some values into some functions and find out whether they are even or not. So let us press pause and have a go at these to find out whether they are even. If not, stay tuned because I'm going to work it out. For example, the first one we have here, f of x equals 9x. We're going to test and see whether it's even. So if it's even, it means that f of minus x should equal to f of x. So in this case, let's see what's happening with the first example. So we have f of x equals 9. So if I have f of minus x, I'm substituting the minus value there. We're going to have 9 times minus x. And if we get the original function, which is 9x, then it is even. But in this case, we get minus 9x. So it's not even. Let us look at the next example. F of x equals x squared minus 8. So we input our minus x. So f minus x minus x all squared minus 8. If we get our original function, then it is even. Minus x all squared gives us positive x all squared minus 8. So this is even. So this function is even. Let us look at the next example. We have f of x equals x cubed plus x squared. So we input f of minus x, and then we have minus x cubed plus minus x all squared. And what we get here, we get minus x cubed when we cube minus x, and then we get plus x squared. So looking at the original function, it's not the same, so it's not even. And then we have f of x equals sine 4x. So we input minus x, and we would get sine 4 minus x, which when simplified gives us minus 4 sine x, which is not the same thing as what we have. What you can do to find out whether this is true, you could input a value of, say, x, say 10. So if you input, say, value, you could just check to find out whether it's correct or not. So if you put minus 10 in there, and you have sine minus 40, that would be. When you check it with positive 10, if you input sine of positive 10 in the original function here, 4 times 10, that would be 40, and you test it, you do not get the same. So let's look at the next example. We have f minus x equals to 2 cosine minus 3 and then minus x. When we simplify this, we get 2 cosine 3x. You can always do a quick check. You could input a value, say x as 10 in the original function, and then you test it with the minus. So if you put 10 there, you're going to get 2 cosine 30. And if you put minus 10 here, you would see you get the same answer. So minus 10, that will give you 2 cosine minus 30, and you should get the same as 2 cosine 30. It's the same answer you get there. Okay, thank you for listening, and I hope you do understand the algebraic and the geometrical significance of even functions.